In this video, we will talk about rational functions. Rational functions are generally written as y is equal to ax plus b over cx plus d, where a, b, c, d are elements of a real number, so they're constants, where c is not equal to 0. Rational functions, they generally come with horizontal asymptote and vertical asymptotes. Horizontal asymptote is where we need to look at the behavior of the functions as x approaches positive infinity, what happens to an y value. As x approaches negative infinity, what happens to the y value? Where are these numbers approaching? So we need to study these two things in order to define a horizontal asymptote. Vertical asymptote is basically where it's undefined. In order for a function, in this case of fractions, to be undefined, the denominator must be equal to 0. So denominator equal to 0 and solve for x. In this case, we have cx plus d is equal to 0. Therefore, x is equal to negative d over c. That's where the vertical asymptote is. Again, rational functions, they are generally common ax plus b over cx plus d, and they have the characteristics of having both horizontal and vertical asymptotes. Let's look at two examples in here where the first function is y is equal to x and the other one is y is equal to 1 over x. By now, yes, we know what these functions look like, but let's pretend that we don't. Well, y is equal to x, that's from algebra 2, or we could even argue algebra 1. This is a one-to-one function where if x is equal to 1, y is 1. When x is equal to 2, y is 2. When it's a 0, it's a 0. Negative 1, y is equal to negative 1. So yes, it's a linear function that passes through the origin. In case where y is equal to 1 over x, we know it has a vertical asymptote when denominator is equal to 0. The denominator, x, is 0. So that's actually on the y-axis. So that is my vertical asymptote. Let's look at the horizontal asymptotes. Horizontal asymptote, like we said in the previous video, we need to study the behavior as x approaches positive infinity and x approaches negative infinity. As x approaches infinity, that's a really big number. So if you think about 1 divided by 10, 1 divided by 1,000, 1 divided by 1 million, we can see this is going from 0.1 to 0.01 to 0. Many zeros and 1. So these numbers are approaching 0. So we can say in that case, y value is approaching 0. So as x goes to infinity, y is approaching 0. So it looks something like this, right? As x gets closer and closer to 1, so at 1, it's at 1, right? And we know if x is equal to half, 1 over 2 is equal to 2. If we have 1/3 as an x, we know that it's 1 over 3, which is equal to 3. So between 0 and 1, the values of y are increasing. So we have a function that looks like this on the first quadrant. And let's compare what happens on the left side of the axis. So we have negative 1. When x is equal to negative 1, the y value is obviously at negative 1. But as x value gets smaller and smaller and smaller, so we're dividing by 1 over negative 10, 1 over negative 100, 1 over negative 1 million. What happens to these values? The first one is negative 0.1. Second one, negative 0.01. And then we have negative 0.000, many zeros and 1. So again, we can say as x value goes smaller and smaller and smaller, y values are again approaching the zeros. So in both cases, we can summarize as an absolute value of an x as it goes to infinity. So as x goes to positive infinity and x goes to negative infinity, in both cases, the y values are approaching 0. So that's where the asymptote is on this function. Y equal to 0 is again on the x-axis. So that's where the asymptote is. So let me maybe try to do it in another color. So asymptote is on the y-axis. Asymptote is another one on the x-axis. Right? The rest is just plug it in. So we already said that when x is equal to negative 1, the value of y is negative 1. And then it gets closer and closer to 0 as the x is decreasing. And then as x value is increasing from negative 1 to 0, we have, for example, x equal to a negative half is equal to y equals y 1 over negative 1 over 2. So that's going to be negative 2. If x is negative 1/3, we have 1 over negative 1/3. That's equal to negative 3. So you can also argue between x value of negative 1 and 0, the value of y is decreasing. Let's graph y is equal to 2x plus 1 over x minus 1. On this radical function, we know we're going to get horizontal asymptote and vertical asymptote. The vertical asymptote is when the denominator is equal to 0. So we know when x is equal to 1, that's where the vertical asymptote is going to be. So at x equals to 1, that's where the asymptote is. Right. Again, asymptotes are like a line, so you can't just say 1, but you want to write that into an equation. X is equal to 1. Right. Let's find out the horizontal asymptote. We need to think about where the case of as x goes to positive infinity, what happens to a y value. As x goes to negative infinity, what happens to the y value. Where are these numbers approaching? So if x is really big number, positive infinity, so then we can think of this fraction as 2 times a really big number, right? A really big number plus 1. And then we have a really big number minus 1. So if this really big number was 100 trillion thousand, that plus 1 and minus 1 is so small that it is negligible. So it doesn't matter whether you're adding 1 or subtracting 1 if you have a really big number to start it with. So then what we end up doing is we're looking at the 2 times a really big number divided by that big number. So it becomes 2. Therefore, as x approaches infinity, y value is approaching 2. Alright, let's think about what happens as x is approaching negative infinity. In this case, we're going to have 2 times that negative trillion thousand, and then plus 1, and then we have that negative trillion thousand, really big negative number, minus 1. Again, when you're dealing with a number that's so big, that plus 1 and negative 1 are just so small compared to that really big number, so you can kind of ignore those two. So we are dealing with 2 times negative b and divided by negative b. So here again we have 2. So as x is approaching negative infinity, we have y value is equal to 2. So that's 1, 2 over here. So here are my two asymptotes. X is equal to 1 and y is equal to 2. We are halfway there, so let's plug in some values and see what the graph is going to look like. The easiest one is when x is equal to 0. When x is equal to 0, it's 1 over negative 1, so you're at negative 1. Right. How about trying to figure out the zeros? On this fraction, it's equal to 0 when numerator goes to 0, right? When numerator goes to 0, the whole fraction goes to 0. In this case, when x is equal to negative half, that's going to be 0. So as x is approaching negative infinity, y value is approaching 2. So as x gets smaller and smaller and smaller, the y values are going to get closer to that 2. But not really crossing the 2. And again, we need to pass through this point, and it has an asymptote at x equals to 1, so it's going to look like this. Right? And these functions, the rational functions, they always come in pairs, so the other one is going to be right across from that graph. Which makes sense because we already said that as x is approaching positive infinity, y value is approaching 2, right? So as x gets bigger and bigger and bigger, the y values are going to be approaching 2. So there are two more things that we need to summarize before going into the next slide. As x is approaching 1 from the left, y value is approaching negative infinity, right? As x value is approaching 1, so from the negative side, it's approaching negative infinity. As x value is approaching 1 from the positive side, the y value is approaching positive infinity. Do you see that? As x value is going positive infinity from the right side, the value of y is going to positive infinity. Given y is equal to 6 over x minus 2 plus 4, find the asymptotes, intercepts, and finally sketch. We're given a fraction and then an integer, but is there a way that we can combine these two things together? Yes, of course. By finding a common denominator, we can say y is equal to common denominator x minus 2. So we have 6 on the top plus 4 times x minus 2. Right. Simplifying, we have y is equal to 6 plus 4x minus 8 all over x minus 2. Right, one more time, we have y is equal to 4x minus 2 over x minus 2. Alright, so in order to find the asymptotes, the one that's kind of easy is always the vertical asymptote. Vertical asymptote is when the denominator goes to 0. So at x equals to 2, that's where the asymptote is. The other asymptote is considering two cases where as x goes to infinity, what happens to the y value? As x goes to negative infinity, what happens to the y value? Right. If x value is a really, really big number, you plug it in here with the logic of 4 times a really big number minus 2 over a really big number minus 2. So that negative 2 compared to that really, really, really big number is so small that we can kind of ignore those negative 2's. So we're left with 4x over x. So that becomes 4. The negative is exactly the same logic. You have the 4 times a negative really big number minus 2 over negative really big number, again minus 2. So that negative 2 is again so small that it's negligible, so you're getting a 4. So y equals to 4. So these two resulted in y is equal to 4 is going to be your other asymptote. So the answer to the question is that x is equal to 2 and y is equal to 4. Where are the intercepts? That's a plural. That means x-intercept and y-intercept. So when x is equal to 0, what is my y value? When x is 0, you get 4x minus 2 over x minus 2, so you get positive 1. When y value is equal to 0, that's when in this fraction the numerator goes to 0, right? So 4x minus 2 is equal to 0, so 4x is equal to 2, x is equal to 1/2. So 1/2 and 0 are going to be my x-intercept. All right, so we have to now sketch x and y axes. Now this is super easy, right? X equals to 2, that's where the asymptote is, so right around here. And at x equals to 2. And then the other one is when y is equal to 4. So right around there, y is equal to 4. And we know the asymptotes are happening at 0 and 1. So 0 and 1 right there, and negative half and 0, so right in between 0 and 1. So must be that it looks like this. So the other pair happens right over there. So that's how you do this problem.